Hello, everyone. My name is Grant Faber, and I am a Techno-Economic Assessment Researcher with the Global CO2 Initiative at the University of Michigan. And today I will be introducing our Techno-Economic Assessment template that was created as part of the AssessCCUS project, which was funded by the U.S. Department of Energy and involved the creation of the website assessccus.globalco2initiative.org. And the purpose of this website is to provide accessible resources related to life cycle and techno-economic assessment for carbon capture, utilization, and storage technologies to a wide variety of audiences. And as you may have seen, this website includes overviews, databases, videos, and of course, these templates, one of which I'll be talking about today. So this video describes our techno-economic assessment template. We filmed a separate video for the LCA template, and more types of templates may be coming in the future, so you should keep your eyes out for that. These can be downloaded in the template section of the AssessCCUS website as well. So to start, this template exists as an Excel workbook, and you'll need Microsoft Excel to actually be able to access this and change things around. You can see these different worksheets for the template on the bottom here. These worksheets reflect kind of the different steps or the different stages of performing a techno-economic assessment. This first one here is just the about page for the template. Features some background information that I'll go through in a moment. One thing to note is that everything in this template is based off of the Techno-Economic Assessment and Lifecycle Assessment Guidelines for CO2 utilization, version 1.1, which are published by the Global CO2 Initiative. You can find links to those on the initiative's website. And you should keep your eyes out as well because a new version will be coming in 2022 as well. And so one final thing to note before we get into this here, there may be improvements to this template over time. We may update certain aspects of it or change certain things around. So there's a slight possibility that the version you're looking at on your own computer will look a little different than the one presented in this video, but the fundamental structure should still be the same. Okay, so to start, we have this first just quick about us page. This has a little background and template. You can find a link to the guidelines here. If you click on this, it brings you to the Global CO2 Initiative's website. The purpose. So, background of this template is really just to help streamline the process of conducting TEAs, specifically for CCUS tech, but it can really probably be adapted to multiple different kinds of processes, but we had carbon capture, utilization, and storage in mind when we were making them. How to use, so I'll be going through this now, but essentially you just fill out the different areas in different worksheets, plug in data to the inventory worksheet, and then plug in various formulas as needed to try to calculate final results, and then interpreting those. And hopefully it's designed such that that's straightforward when you go through the template. So in terms of audience, basically anyone who's interested in TA, either learning more about it, doing their own, may find value from this template. Specific groups we've identified include technology developers, assessment practitioners, so people doing LCA and TA, entrepreneurs, researchers, and so on. Just a couple quick tips for using the model. I'll hopefully mention these throughout the video today here, but we find that listing sources as comments on the cells is really helpful. And so what I mean by that is maybe leaving a note on methodology, why you chose particular data, but it's really especially the source of that data. So almost like a small citation, just to help yourself or others kind of locate that data. And it's also extremely helpful in the future, when a few months go by and you're trying to figure out, well, where did I find that data? Well, leaving it in a comment is very helpful for that. We've also designed this template with notes areas, so you can leave some notes about different inputs, which can help if someone else is looking at the model and to whom things may not be entirely clear. The note can help make it clear what a given parameter is representing. And we'll talk about that in a moment. Avoiding formulas inventory sheet, I'll talk about that a little later on. And on and off switches for scenarios and other things is also very helpful. Potential template expansion. So of course, with just kind of this TA template, kind of a simple Excel workbook meant for lower TRL technologies where maybe there's not as much data yet, not as many things to model. With that, because that's what the template is for, there's a lot of potential expansions. And so there's really a wide range of things here. There's more advanced equations that you could put in, expanded calculations, more space, which I'll mention, allocations, loss rates, cash flows, and so on. You can go through the list and probably think of even more things, more ways to expand this template. But the idea is just to help people get started and just to have a baseline that can help identify cost hotspots on research and just kind of provide some high-level guidance in terms of what researchers might want to focus on when they're developing and trying to commercialize a technology. Finally, we just have a little disclaimer that also may be updated with time. So let's see, we'll move on to the goal. So first, you can see this little title section. Often, if I'm personally using the model, I'll just push the About page to the end, or I'll get rid of it, and I'll just put the title and some details here, again, to help others if they're looking at this model in a kind of separate context, and they feel like they need to get in touch with me, or they just want to know when it was included. This kind of information is very useful. Jumping in here, you'll see that the worksheets are mostly organized with this format, where the title of the worksheet will be in green, and then subsections will be in this kind of darker gray, or under these darker gray headings. And so here is just some different, basically titles of things that have to do with whatever your project might be. Something to note here before we get into it is that this template is currently modeling just kind of a generic chemical process. And so this isn't reflective of any real process. Maybe we pulled in a couple things that relate to a real process, but it's really meant to be a generic template filled with placeholders that can be changed around according to your own individual needs as you're going throughout the template. So anyway, these sections kind of represent different areas, different things recommended by the Global CO2 Initiative's guidelines that you should kind of address before going into a study. So you'll see these on the goal, scope, and interpretation pages, these kinds of boxes that are meant to be filled in. Just a quick note, you may want to expand this depending on the complexity of your study or how much you have to say about a particular component here. You may want to add a couple lines here, or insert a couple rows, and just kind of add more information as needed. It's really meant to be a flexible template in that sense. So one other note too, throughout the template here, I've put these snapshots that come usually directly from the Global CO2 Initiative's guidelines. And these snapshots are just of different aspects of the TEA guidelines that may be useful to you as you go throughout using this template. So here you'll see TRLs, or technology readiness levels, kind of listed out 1 through 9, and just reading through these can help you get a sense of, for your particular technology, when you're filling out this template, well, where does your project fall along here based on these descriptions, and that can help you kind of fill that in there. So I won't go through every single box. Hopefully a lot of these, it's pretty apparent what like location, use, and assessment. It's pretty apparent what is meant to be in that box here. And of course we have the generic placeholder information for a lot of this. On the goal page, it's really just a lot of background information. You know, what's the purpose of the study, who's commissioning it, who's going to use the results, what kind of research questions are we trying to answer. One thing here in the bottom of the goal worksheet is a section for different scenarios that one may want to assess as part of a study. So here are sort of default ones. We have base case, just kind of the baseline or default scenario that's being used in the study. And then we just have one for using low carbon electricity in the study, which maybe entails different costs, something along those lines. And then maybe raw material replacement. And so a given study may have no scenarios, it may have many more than this, and you can just, you know, add more below here as needed. But yeah, this is just kind of the section to outline what goes into those scenarios. So moving on to the scope worksheet. So what we have here is kind of getting in a little more into, well, what is the study actually focusing on? What is the product? How are we assessing it? On what basis? what's kind of the system that we're looking at. So again, here you can see there's another snapshot from the guidelines themselves, definition of product systems and functional units. This will hopefully provide just a little bit of guidance on thinking about setting a functional unit for your study, which is essentially like a basis on which you're trying to allocate costs or impacts for the indicators. So there's some guidance. There's a lot that goes into, there's a lot of thought that needs to go into properly setting things like functional units and reference flows and so forth. Scrolling down here, there's an area that talks about the actual system elements. So what are the different processes that are actually being assessed as part of this system? So maybe you have a system and it takes a series of raw materials, and then they undergo different processes that themselves make use of various materials and energy to process the material into something new and useful. And we really want to map that out in this section and really understand, well, which processes are being assessed as part of this, this assessment. What are we looking at? What raw materials are being covered? And so forth. What kind of energy is being used? Here you see we're using electricity in presses 1 and 2, but natural gas for process 3. And so those are the kinds of things that you really want to outline and be sure that you understand in terms of what goes into actually creating this product and what goes into this system. But it's also very important for our costs. As you can imagine, we need to understand, well, how much these raw materials cost, how much does energy cost, the equipment to actually perform these processes. These are all things we need to understand to be able to fully build the cost model, and you want to be very transparent when you're doing the assessment, when you're going through here. You're going to be really transparent in terms of what is being included and what is being excluded. And so because of that, it's important to fill out this part of the worksheet. And it also provides for kind of a common understanding. If multiple people are using this template and kind of looking at it, you'll want to all be on the same page about what's being assessed and what you're looking at. Scrolling down here, we have other aspects that are generally considered as part of the scope. One thing to note here is we have a couple indicators that we're assessing in the default version of this template: manufacturing costs, percentage of manufacturing costs attributed to these different categories, and then the amount of CO2 utilized in the final product. Now, when you're going through the template, maybe you're only concerned about manufacturing costs and you would just want to cut these totally, or maybe you're concerned about many more indicators that you want to add in. And just again, the template is meant to be completely flexible, and it's structured in a way such that it shouldn't be too difficult to try to insert rows here or something like that if needed, to insert space for more indicators. So with that, I'll move on to the inventory worksheet. So here you can see there's some different sections. This basically lists all of the different parameters used by the model, so all the different individual data points. When putting this together, we chose to keep formulas, so Excel formulas, out of this sheet, and just have it be such that these are just numeric inputs. And so if you see here, if you go up to the top bar here, to the formula bar, it's just inputs. It's just raw inputs here. And the reason for this is so that in the future, if someone goes to change these, there's no concern about them changing a formula and then needing to remember what formula was there or to look at an earlier iteration of the model. With this structure, we're essentially keeping all of the inputs to the model isolated on this page, just so that they can easily be changed later. And it just helps keep everything a little cleaner and separate. So first section here, start going through these, is just production parameters. So just high level things about the process, how much is being produced, how many people are working, and so forth. Here we have scenario specifications. So essentially in these boxes, if they're both 0, we are modeling the base case, the benchmark scenario, just kind of the default. But if you change either of these to 1, it then turns on that scenario, and that then propagates through the rest of the template and changes things as needed to make it such that the indicators in the indicators tab will reflect the use of parameters related to this scenario. And so, yeah, you have to be somewhat careful here. You don't want to turn multiple scenarios on at once because that might lead to non-meaningful results. Or if you do, you just want to be very clear. So if we were to turn both of these on, it would mean that we are both using low carbon electricity in the process, as well as using the replacement for the raw material. So just something to keep in mind. And again, if you add scenarios as part of the goal, you'll want to add them here as well with corresponding cells. Here we have material flow. So this is kind of just a simple view of the different raw materials going into the process. You can see here, this is for the second scenario. So this data isn't used in the default scenario, but if this switch gets turned on for scenario 2, then this number does get used in the following worksheet. But yeah, these are just high-level views of how many liters of raw material 2 is required per kilogram of the final product produced. Just a quick note, you can see here, it says right source here, and that relates to what I was saying before about including comments on these different inventory parameters, just so, again, it's easier to find later. If you're looking at this model in a couple months or something like that, or if someone else is looking at it, it's good to be very transparent about that. And if you end up writing up these results, the results of this assessment as part of a report or an article, a journal article, it's very helpful to have these sources handy. And then we have this notes section here for each of these, which is also, these are also meant to make it clear what each of these particular entries are. Here we have a whole section on cost parameters. So this is just different piece of data specifically related to the cost of different aspects of the process. So here you see we have things to do with inflation, not so much factored in to this model, but here nonetheless, we have raw materials, costs, energy, labor, and then we have some percentages and some factors related to the actual property, plant, and equipment. And finally, here we have machine parameters, so the different pieces of equipment that are used for all of the different individual processes as part of the system. We have different parameters representing each of those machines that are then used throughout the model. So I won't go too much into the methodology here, but essentially what this is doing is it has a reference machine, and that just has kind of default cost and throughput capacity data. And then that data is scaled based on the needs of the process. And so instead of having a model where we're buying multiple machines to handle, say, a larger quantity of material that needs to be processed, we have a kind of scaling factor built in to the model that is scaling machines. So if we need to process more in a given step, well, we need a bigger machine, and that machine will thus cost more. Although we do also have a manual way to input the number of machines in each step. So if you are processing a very, very large amount of material in any given step, and you imagine that it's unreasonable to, say, have a reactor the size of a football field or something like that, then you would need to, as the model is now, manually go in and maybe adjust the number of machines to represent something that might be a bit more of a reasonable size. And so that's just how the model is right now. You may want to modify that as you're diving into this template. But yeah, this section just in sum contains a lot of different parameters related to the machines. And then here we have a sensitivity analysis and uncertainty analysis working section. And so in these sections, we have data tables that are varying different parameters in the study and seeing how the final indicators change. And as the note here says, this really doesn't belong in the inventory worksheet, but because of requirements in Microsoft Excel, if you go to do a data table, it needs to be done in the same sheet where the input is. And so because we have, say, a static input for something like production volume, and we want to analyze how the final costs change with this data table, we have to do it in this worksheet. So that's why this is here. Technically, this is done as part of the interpretation phase of the study, which is this final worksheet or final stage here. So just something to note that you'll need to, after doing the indicators, in order to actually get these values to vary here, you'll need to come back to these sections and run these analyses. But we have one for uncertainty. If you're uncertain about a given parameter and you want to test how the potential range of it might affect the final output, it's in that section. And sensitivity analysis, if you want to test, for example, how sensitive the results are to different parameters here. And now there are, I should add, Excel add-ins and other pieces of software that can greatly facilitate this kind of analysis. For example, you may want some code or some kind of add-in to help generate tornado charts or spider charts or something like that to help do the sensitivity analysis. So you may want code or something to help with, say, doing a Monte Carlo analysis for uncertainty. And that's not included in the default version of this template, but again, it's designed to be flexible. So if you want to add that, it's something to think about and investigate as you're working through this here. Okay, so we'll move on to indicators. So here there's kind of three main sections. It's maybe not in the perfect order because the first place to go is probably intermediate calculations if you're kind of working directly through this model. So the indicator summary is here because when one clicks on the indicators tab, you expect to see the final results of the study just right there. And so that's what's in this section, and then the cost model is off to the side. But we'll start by going through intermediate calculations. So essentially what's in this section are calculations that support what is in the ultimate kind of cost model or the kind of core model that makes up the TEA, but that you don't input directly into the inventory because they're not, say, direct numeric parameters. So for example, annual operating hours is something that is based on the operating capacity of the plant, which in this default model is 90%. And if you look up to the formula bar, you see that, okay, it's multiplied by 365.25 days per year, so accounting for leap years, times 24 hours a day. And so because there's an actual formula here, and this isn't a number that we necessarily want future users of the model to directly tinker with, it lives in this intermediate calculations area. And you can see for all of these other entries here, scaled machine to cost, something like that, if you look up at the formula bar, there's a specific formula there, and it's being modeled as this kind of intermediate result, which then flows through to the cost model. And so you take those intermediate calculations and you use them to put together what we have here on the right, which is the actual cost model. So what this is trying to do is for the raw materials, production labor, and overhead for the process. It's calculating these different subcategories and basically calculating the total cost per year and then the cost per kilogram of final product produced. And all of these numbers are then combined in the final indicator summary in these columns D and E here. You see they're combined for all of the different constituents of the process, so we can basically calculate a final indicator for, well, how much does it cost to produce each kilogram of the final product. But anyway, back to the cost model. Specifically, you may, of course, need to modify this significantly. Your given process or system may include more or fewer raw materials, different kinds of labor, although generally direct labor, indirect, and fringe, like representing benefits and whatnot. Generally, this represents a lot, but will reflect the types of labor costs that a lot of projects will see. But you may want to use different names. You may, the person commissioning the study may expect you to kind of reflect this differently in the model. But anyway, the point here is that it's all flexible here, and you may need to add or exclude certain things that are included here as needed. The only thing is when you go to do that, you want to make sure that any kind of summation formulas or anything like that adjust properly. So if we get rid of raw material 4, for instance, we want to make sure that the summation here on the bottom, you see it says sum R10 to R13, that updates properly. So you can change things, and it's recommended, and you'll have to create a model that actually is accurate for your given process technology that you're modeling. But you will need to engage in some level of debugging just to make sure that everything is working as expected. Another note on the cost model. So we have capital equipment costs kind of separately on the bottom that feed into this capital equipment line here. So just it's just a kind of stylistic decision. You may want to calculate capital equipment costs in this method, maybe in the intermediate calculations or maybe in a separate area altogether. It's just kind of a stylistic decision we made when making the template. Furthermore, you may notice that all of the processes are represented in just this set of columns, but like this box here says, you may want to actually expand this and have one of these kinds of areas of the cost model for each individual process in the system. So in this, because of what the scope was saying, you know, we have process 1, process 2, process 3. You may want a specific area for each of those processes to have basically a breakdown to see, okay, well, how much is each individual process contributing to the overall manufacturing cost of this final product? Here it's simplified. The idea is that the goal only necessitates looking for like the biggest contributors to the cost, and that breaking down by step isn't necessary. But if you do desire to increase the granularity of the results and basically get more of like a deeper understanding of what the biggest cost contributors are and where you should kind of target, you may want to kind of expand this cost model to the right. So you would want to, you know, add some columns here, copy this, and then put in data that's only applicable for each step. So finally, we just have this indicator summary area. I already touched on this, but essentially this is just the area where you want to summarize all of the different desired indicators for the study. So here, as you can see, we have this one indicator, you know, the cost, the final manufacturing cost per kilogram of the final product, around $3,000 here. We have these distributions as well, which are reflected in this kind of high-level pie chart here. And so you can see how costs are distributed among these different categories. And then the third indicator here is the amount of CO2 utilized per kilogram of the final product. And so again, you'll want to expand this section if you have more indicators, shrink it if you have fewer. Also, if you're interested in making more graphics and data visualizations, there's not necessarily room to do that here. So if you want to do that with this data, you may find it helpful to, you know, highlight that data, go to insert charts, and then insert whatever charts you want in this kind of working space down here below the cost model. But it's up to you. You can also do a separate outputs sheet. There's really a lot that you can do in terms of that. So finally, we have the interpretation worksheet. And so this is meant to be filled in after the rest of the sheets are already completed. Now, technically, interpretation is an iterative process in TEA. So it's something that you would be doing along with all of the other steps. So as you're filling out the inventory, as you're calculating the indicators, you should be thinking about, okay, is this study helping me? Is the way I'm approaching the study helping me actually meet the goals set out in the goal phase? And if it's not, you know, you want to go back and kind of change things around, or say you can't find certain data that you need to achieve a particular goal, then you may need to go back and refine things. And so you know, you'll be doing the interpretation of your results kind of throughout the whole study. But the way this worksheet is structured within the template is basically summarizing. Once you do have final results that you're more or less satisfied with, you know, you'll have these what we're calling insights here, which are basically just conclusions. You know, what are you seeing from the model? What are the indicators? What are the implications of, say, the different scenarios, or scaling the process, or something along those lines? Then we have a space for recommendations. So you may or may not want these depending on the type of study you're doing. Here, these recommendations are kind of normative, and the assumption is that reducing the cost, for example, or improving the other indicators is something that's actually desirable. And so the recommendations here are basically recommending, well, where should a researcher, for example, focus to make this product cheaper, to make it more economically viable? And as you can see from the indicators tab, you know, manufacturing overhead was a very small component, whereas raw materials was very large. And so a very basic high-level recommendation would be something like, a researcher should focus more on innovating and finding different and cheaper raw materials rather than worrying too much about energy consumption if their interest is in reducing the cost, or something like that. Now, of course, any recommendation needs to be viewed in a broader context, and there are environmental implications. What does the LCA look like? Is energy important in the LCA but not here? So, and that would influence the kinds of recommendations that one would want to make. But basically, this is just a section to write about them, to maybe offer some thoughts on that. Again, you can just delete these rows or these boxes if it's not useful. And then finally, we have these sections for scenario analysis, sensitivity analysis, and uncertainty as well. And these are just offering some observations and summaries of, well, what did we find? So when we turn on the switch for low carbon electricity, when we turn it on for raw material replacement, so forth, what are we finding? Same with sensitivity and uncertainty analysis. As we kind of vary the parameters within certain ranges, how are we seeing the results change? And kind of what does that mean? Is it expected? Why is it happening, and how might it be useful? And then just finally, a small note here that you can see in the sheet, but we only looked at a couple of variables here for uncertainty and sensitivity analysis. So this is really just a kind of a sample of what this could look like. A full study may want to assess the sensitivity of like every parameter in the inventory list, and so that would mean that this section would be much larger, and that the analysis would be a little more in depth. So it's just something to keep in mind, again, to this theme of, just change things around as needed to meet your own needs. This is really meant to serve as like really just a kind of jumping off point, just to help you get started, and to show the general structure and trajectory of a techno-economic assessment according to the Global CO2 Initiative's guidelines. And so with that, it concludes the overview of the Global CO2 Initiative's Techno-Economic Assessment template. Please look out on the AssessCCUS website for updates and possibly new templates with time. And please contact us on the globalco2initiative.org website with any questions or comments you might have, or any feedback for things to add to the site or improving the model. And with that, thank you very much.